Okay, Assalamualaikum and hi all. So today I'm going to continue on chapter 3, multiple integrals. We start with iterated integrals, topic 3.1. In this, by the end of this subtopic, you should know how to evaluate iterated integrals. Evaluate or solve iterated integrals. What is iterated integrals? Iterated integrals, we also can say as repeated integrals, or in other words, we can have double integral or triple integral and so on. To solve this one, to solve iterated integrals, you should know that how to start this one first. To start integrate double integral or triple integral, we start from inside out, meaning that if you have dx dy like this, so you start with inside first, dx first, and then for dy, and then integrate to respect to dy. To regain more understanding, of course, I'm going to show you by using exercise 1.1, page 86. So evaluate the following iterated integrals. Following iterated integrals. So first thing, as I mentioned just now, we start from inside and then you integrate outside. So integrate the inside first. The outside you just copy. Okay, integrate outside you just copy. Okay, integrate inside. Integrate 40 to respect to x. Integrate, you get 40x. Integrate, not differentiate. Integrate. Okay, next, integrate 2x to respect to x. Y become constant. 2 is constant, y is also constant. So to integrate, constant always follow. So you just integrate to respect to x squared over 2. Okay, so you get the answer here. No plus c because you have the limit. Okay, next, you insert the limit first. To insert the limit, okay, insert the limit. Since you integrate to respect to x, insert the limits into x, not y. Integrate to respect to x, insert limit to x. So 2 to 4, you get 40. Insert value of x minus 2, you can cancel out, so you get 3 squared y. And then minus with limit on the bottom here, which is 1. So 40 times with 1 minus 1 squared y to respect to dy. Please ensure that if we have this one, of course we have partner, which is to respect to y or to respect to x, to respect to z, and so on. Okay, next, continue. You try to simplify. 2 to 4, simplify. Inside here you will get 80 minus 8y dy. Okay, now we solve for with respect to x. Now we want to solve for respect to y. Okay, to respect to y, integrate 80, you get 80y minus 8y squared over 2. Okay, from 2 to 4. Integrate to respect to y. Of course, the value insert into y. Okay, so insert into y, you will get at the end, and the answer is 112. You can try to solve and simplify. You get 112. Some of students might not understand when involve more than one variables. I repeat, if you want to integrate, let's say 1 dx, you will get x plus c. 1x over 1 plus c. If you want to integrate, let's say 2 dx, you will get 2x plus c. If you want to integrate 2x dx, you will get 2x squared over 2 plus c. If you want to integrate, let's say 2 here, I change to y. Y. Okay, x dx to respect to x, so you get x squared over 2, and the y here follow. Same as here. 2 here, you follow here. X squared over 2. This one, y x squared over 2 plus c. So, when you want to integrate to respect to dx, if there is y inside, y become constant. If you want to integrate to respect to dy, if there x inside, x become constant. Okay, we try one more time for example B. Okay, example B. Okay, double integral. First, you solve inside first. Okay, the outside you just copy. Okay, copy. Integrate from 2 to 3. Dx. So inside, how to integrate to respect to y? So x become constant. 3x constant follow. So you integrate y become y squared over 2 plus, okay, integrate to respect to y, you will get 2 follow y power of 3 over 3. Okay, from 0 to 1. Okay, insert the value 0, 1 and 0 here to y because you integrate to respect to y, right? So insert into y. So 2 to 3. So you will get 3 over 2 x insert into y squared plus 2 over 3 insert into y power of 3. Then minus with limit at the bottom here, which is insert value of 0 here, you will get 0 plus you insert 0 here, you will get 0. So to respect to dx, always have the outside integrate because we don't integrate yet, so you need to copy until you integrate the dx. Okay, next. You try to simplify, you will get 2 to 3 3 over 2x plus 2 over 3 dx. Next, we have dx only, and so we want to integrate to respect to dx. 3 over 2 x squared over 2 plus 2 over 3 x, integrate 2 over 3 become 2 over 3x from 2 to 3. Then you insert the value, you will get 53 over 12. Try upper limit inside. For those who didn't get what I said, 3 squared over 2 plus 2 over 3 minus insert value of 2. 3 over 2, 2 squared over 2 plus 2 over 3, 2. And then you get this one. Check your answer, yeah. Okay, some of you might be forgot about integrate, so I recall about some of integration. So based on the appendix here. So based on the appendix here, so just based on the appendix here, you see from the table integration formulas here. So based on integration formula here, okay, integrate x squared, let's say you get x cubed over 3 based on this formula, and then you can see this formula, others formulas as well. And if let's say you want to integrate in 3 differentiate cos, you get negative sine x. So if you integrate sine, you get cos. You integrate negative, you get negative cos. You should know how to interchange it, because when you differentiate you get answer, and when you integrate the answer you get back the integration answer. So integrate, let's say sine, you get cos. Integrate cos, you get sine. Okay, next, let's say we involve more than one variable. Let's say you have fx and gx. To solve something that have fx and gs, or two function that cannot be solved integrate directly, you have only two methods, which is one substitution method, and two is by part or tabular method. First, consider substitution method first. So to know substitution method, one, you consider it one first, and another one to know is one of the function is derivative of another one. So this one can use substitution method. Let's say this one. So let's say sine is derivative of cos, right? And cos also derivative of sine. So this one is might be bit possible for substitution. So you can solve substitution by using substitution. Let u equal to, let's say you choose sine x. So differentiate du over dx. Why you differentiate? Since you let this one as u, you want to integrate to respect to du. This one become u, so you want to have du. So to have du, you differentiate lah. So du over dx, you get cos x. I want du only, so du is cos x dx. So cos x dx is actually du. Okay, cos x dx is du. So this one is u. So you can integrate lah. Now, so you will get u squared over 2 plus c. Since no limit, so you need to have plus c at the end. So change back u into the variable of x, since we integrate to respect to x. So u is sin x, and it have squared over 2 plus c. Done. Let's say we have something like this. X, integrate x, exponent x. For this one, how to know we use by part method when the substitution method cannot be done, or another way to determine is by combination of Lopez. Some combination of Lopez can also use substitution. That's why consider the first thing, this one first. When substitution fail to use, you consider by part. Okay, for this one, if you want to do substitution, let u equal to x. Let's say du is equal to 1 dx. So it's not derivative of it. You didn't get the exponent x. Let's say u equal to exponent x. Du is equal to exponent x dx. Still, you didn't get the partner here. So substitution fail to use. Since substitution fail to use, you consider to use by part. By part, you can use formula or tabular method. I prefer to use tabular method. First you differentiate, another one you integrate. Choose the one that comes first. Lopez, logarithm, polynomial, exponential, trigo. So here polynomial come first. So polynomial here x, we choose to differentiate, and exponential come next. So exponential to integrate. So differentiate x, you get 1, differentiate 1, you get 0. Differentiate until you get 0, and this one, since you get 0 at the third step, so you integrate until the third step. So integrate exponent x, you get exponent x. Integrate exponent x, you get exponent x. Okay, so this is plus, minus, plus. If there is some line somewhere, so plus, minus, plus, minus, plus, minus, plus lah. Okay, so here times with here, the first with second, the second with the third. So integrate x exponent x dx is equal to x exponent x minus exponent x plus c. Don't forget plus c, because there's no limit involved. Okay, so for this one, let's say for the last example, let's say I have cos squared x. This one you cannot solve substitution. You also cannot solve by part methods. Because this one cos multiply with cos, become cos squared. Cos times with cos. First they to use by substitution, there's no partner that derivative of it. And if you want to choose by part, there's not combination of Lopez. So how are you going to solve this one? You can change into trigonometry identities. Just now it show trigonometry identities. You can choose from here. You rearrange cos squared x, you will get 1 plus cos 2x over 2. Integrate, so this is the identity. We not integrate yet. It's just the identity. To change the form first, then you can solve by using directly, or by that two method substitution, or by part. Okay, from this one, we can direct integrate. So 1 over 2 I take out. So integrate 1, you get x, plus integrate cos, you get sine 2x over 2. So the answer is this one plus C. If some functions not involving triangle might be is involve partial fraction or long division. Please see your books BMMU 1023 to recall back, or you can just Google how to integrate somehow if you get stuck on the tutorial. Thank you very much.